Hello everybody, welcome to this lecture on double dispatch. This is an alternate lecture on the other one, where we will really add numbers as a kata, as an exercise. The outline is that we will see some fun exercise that you should do, think about them, and then step back to see what we learn. So the idea is that you will do exercises and I will do exercises with you, where in fact you get access to three primitives: add I to add two integer, add f to add two floats, and as float that convert one integer into a float. With that, we will build addition between numbers. So basically, the goal of the first part of the lecture, this is to support the addition with the same plus message, with the number 1 plus 2, the integer 1 plus 2, the float 1 plus 2, adding an integer plus a float and two floats. And the idea is that we will not use any conditional, any explicit conditionals. So I give first some hints. So you saw in the first lecture that sending a message is making a choice and that classes support choice expressions. So basically what it means that we will have two classes, integers and float. So you see, nothing really new here, so we will really have these two. And by the way, in the second part of the lecture, we will add fractions, so we will have integer, float, and fraction. So what it means that if we have two classes, then we will have at least two method plus, and we will have a third one in a fraction in the future. What I will do during this lecture is that you will have to fill up some text. What I suggest is that you try to do it and you just look at the video. So like that you can pause. When I have fill me up, this means that you can pause and take a pen at home and try to fill it up. So this means that I said that you have two classes, float and integer, with two methods plus a number. So it means that the exercise is to fill up these two classes, these two methods. So another hint that is a bit obvious, but this is very interesting to see it, is that when I execute a method, I know that the receiver of the method is an instance of the class or a subclass of that class. So this means that I have already some information. And we will use this information as part of the solution. Now let's start. So imagine that we add one method that is called sumWithInteger. With the primitive, we know how to do it because we know how to add two integers together. So this means that in the class integer, sumWithInteger should be straightforward. Let's look at it. So sumWithInteger, in the class integer, when I have an argument that is an integer, I will just call the primitive add I with self and the argument, and I'm done. So here there is a strong assumption that the argument an integer is really an instance of the class integer. So now the point is that we know that we have sumWithInteger here. So the question is how do we use this sumWithInteger from the other one? Our idea here is that we are basically working on that. So it should work. Now we should be able to have a solution for 1 plus 2, where 1 and 2 are integers. So imagine the solution. So let's see the solution. So here what I do is that when I do 1 plus 2, this means that this method will be executed. A number will be 2, and then I just send sumWithInteger to a number. I don't know normally that is a number, but at least here in that typical scenario, I assume that this is correct. And since this is an integer, this is this method that will be executed, so I end up with the correct things, with the correct results. Just to explain, let's take this code and we will make sure that we understand where the arguments are going inside. So here, we are looking at the execution on 1 plus 2. So 1 is an integer, so plus will be on the integer class. So this is this method. And you see here, I took the code and I put in parentheses, or I replace the text with the actual argument. So here I said, okay, I have 1 plus 2. This is this call, 1 plus 2. And then I will do 2 sum with integer 1. What is super important is to see that we switch it. And then it means that now I'm looking for sum with integer in the class integer. So this is this one. So I'm calling 2 sum with integer 1. And I end up doing this. By the way, this trick of looking out the argument and the receiver and the argument of the message flow within the text is a really nice way to understand the ping pong that is actually happening during the double dispatch. I really saw that this is really helping people to understand the double dispatch. So now the question is this: what is about 2 plus a float? Because when I do that, if this is a float, I will have 2 here, a number will be a float, and I have 1.2 with 2. And the system will say, oh, I don't know what is sum with integer when I'm a float. So you know what? We should define sum with integer on float. So let's do it. What is sum with integer on float? Take a moment. Normally with the primitives, we know how to do it. So sum with integer with float, this is basically calling add float, add f, with self a float, and to convert the integer as a float. And we have it. So now we have the solution. So this means that when I send a message plus to 2, I will select this method, and then 1.2 will be here because 1.2 is here. And then I will call sum with integer, but on the class float. So I will call this one here, and then I convert, so I'm done. So again, I just did the same, and you can follow, you can press and you can follow. I did the same. I see, okay, yes, it goes like that. This guy is here, and it goes like that. So I call now this guy here, and it's happened. So what you see again, this is that there is something that is really important, is that I send a new message to the argument. What do we do when we add 2 floats? Because before we only add integer, and now we have float. So this means that we have to define plus on integer. So how do we define plus on integer? Take a moment to think about it. But basically, what we should do is that we should define a new method like that. We should set a number from with float. Why? Because we don't know if the number is an integer or a float. So since we don't know, we define plus with as this method. The impact is that we will have to define sum with float on the class integer and the class float. So now, you see, I added sum with float on 2 classes, on the class integer and the class float. So sum with float on the class float, this is easy because I use the same primitive add float with self and a float, because this is a float. And here, sum with float on the class integer, what do? I have a float as argument, so I convert the integer, the argument, as a float, and I add it. And what you see in that, with this piece of code, we can add a float plus a number and a number plus a float. So you can also do the same exercise. What I suggest is that I will not go into the detail, but you see that if I have the plus here, I have a float. So the float means that I will execute this one, and then I will execute sum with float, which is this one, and then sum with float. You see, so you can follow each time the flow of messages. So what you see is that the previous code supported all that. If you do not get it fully, what I suggest you to do, and it works really well, this is to do exactly the exercise of following the argument on the text, on the code. So basically, you take this, and you take cases and you select which methods, where the methods are going and which method is executed. It works really well. So what we see, let's step back. We see that we have two things. We have two kinds of message. We have the message plus, defined on two classes, integer and float. And we have sumWithInteger or sumWithFloat that are defined on two classes, integer and float. And that the fact that I send this message, I am doing a second dispatch. So here I have a first dispatch between the two implementation here, and here I have a second dispatch between the two implementation here. So this means that plus will select the correct one, and then once we send the message sumWithInteger or sumWithFloat, we will also select the correct methods of each of those methods. So now, let's say that we want to add fractions. So a fraction, this is an object with a numerator and denominator, you know, like in maths, nothing special. This is a fraction. And we know how to compute as float, getting the denominator and getting the numerator. And now we want to support this. I want to add a fraction plus an integer. I want to add a float with a fraction or fraction together. How do we do that? First things first, we have a fraction class. And then we define a plus method on this fraction class. You see, it follows the same pattern. So what should we do? Take a moment. You will see, okay, we should basically add probably something like that. Sum with fraction. This is what we did for the previous one. Let's check. Oh, yes, this is correct. And now it means that we will have to define sum with fraction in the class fraction, the class integer, and the class float. So let's start with the class fraction. So fraction in a fraction, you know the maths, this is that kind of things. So let's do it. You see, this is a bit verbose because I send messages, but I create a fraction with a numerator and a denominator, bim, boom, this is done. And now it means that this code supports this, because when I send the message plus, I will select the plus in the class fraction, this one, and then I will do sum with fraction. So this is a fraction, so I will create these kinds of things. So with these two methods, I already support fraction addition, but I want more. I want fraction plus integers and fraction plus float. So let's do it. So now we will define these two methods in the two different classes. So this is exactly this definition. And for this one, we have a float added to a fraction. So we have 0.3 plus a fraction to third. So we will convert this one as a float and we will add it. So here, this is what we do. We said, oh, let's convert the fraction as a float, and self is a float, and then we invoke the primitive add float that will convert, that will take these two and do the addition. So this means that if we see, now we manage we support well fraction plus fraction, a fraction plus a float, and a fraction plus an int. But we have still some things to fix. So what about 1 plus a fraction? So this means I have an integer. So here, when I send the message plus, I will look in the class integer. So I will look for this plus. So what you see is that the definition of plus was really the following. It said, okay, I have a number, and I will send sumWithInteger to this number, here a fraction. So what we have to do, we have to define the method sumWithInteger inside the fraction class. So let's do that. So basically here we end up with the same kind of code because we will have a fraction with an integer. So a fraction plus an integer. So we will do and this is what this code is doing. You know, I create a new fraction where I sum, multiply the denom, blah, blah. So this means that with this definition, now we support the addition of an integer with a fraction. Basically, we should do exactly the same for this case because the receiver can be a float. So when the receiver is a float, what should we do? We should define the method sumWithFloat in the class fraction. So what I suggest is that you do it because I know how to do it, and this is always the same. So now I just want to show you the complete code. So here, this is the complete code for the integration and the definition of the management of fraction. So all these methods, you see, so you have 3 methods in the class fraction and 1 method in integer and 1 method in float, plus the plus to support the integration of addition that can manage float, fraction, and integer. So now you can relax. If you really want to understand for real or if you need it, just take a pen and follow the calls. The code in the previous slide manages all those cases. So this is quite nice, and even more than that, it will manage 1.5 plus 0.5, for example, without problem. So let's step back. What we saw is that the essence of double dispatch, this is in this code. You have a class X, you have your message plus, and then an argument. And then what we do is that we send a new message to the argument. So this means that the system selected first the message based, if we have a X, it will select this one. And here we will have Y that will have plus a something. And then we will do the same, a something, sum with Y self. So the first time when we send a message to a X, it will select this one. If we have a Y plus something, we will select this one. And then we will have the other messages that are the helper message where we will do the second dispatch. So in fact, we have one dispatch and a second dispatch. That's why this is called double dispatch. So what you see is that we could add fraction without changing any of the previous methods. So this is quite cool because this means that we could add a complex number or something else in the story. So this is an illustration of sending a message is making a choice. And this is based on this idea that you have a primary message and double dispatching messages. What you should notice also is that sometimes people do triple dispatch, typically for the library, the graphical library, because they have a canvas, Cairo or metal, for example, and they will select the pen. So is it a line like that? And the texture inside the brush. And they don't want to do checks, so they can do a triple dispatch to do these kinds of things. What you should see is that double dispatch, this is really the essence of the visitor design pattern. And then we will really use it to do the ping pong between a composite pattern and some algorithms that will be applied on those composite structures. So again, the double dispatch, this is a clear illustration of the don't ask, tell principle. And it is often used for event handling and drawings and things like that. Now, one question is when not to use double dispatch. In fact, first, the simple one is that if you don't have a different class to dispatch on, then you cannot use it. This is not that you can, this is that you cannot. Basically, you need a different instance of a different class to be able to dispatch, to execute a different method. Second, what I would say is that if you have a limited case with two, three methods that you have to check, and you know that it will never change, maybe you don't have to bother to introduce double dispatch. What are the drawbacks of double dispatch? So overusing it may force to create a lot of many little classes. It can lead to a design that is a bit more obscure and difficult to follow. So sometimes a simple condition can be good too. You know, we should not be ultimate on that. Design is about trade-offs, and then you have to decide. Now, for you to decide, you should really understand how it works and practice it so that you can say, no, I don't want to use it, or I want to use it. Now, I would like to talk about overloading, because double dispatch is also useful in statically typed language such as Java. Sometimes people don't understand it and they get into trouble. So what I mean is that the typical case, this is a visitor design pattern where you will use only one visit method that is using the overloading of the language, will work sometimes, and sometimes it will not work because the static typing will select the wrong methods. So if you use overloading for visitors, you will learn it the hard way, and I think that in any case this is good because you will learn it. But what I know is that I will not use overloading to support double dispatch because it does not work in reality on real cases. Conclusion. So what you saw is that double dispatch is powerful. We could implement all this conversion between this addition without any conditional. This is modular. We could add the fraction without changing any methods. And at the end of the day, what we did, this was just we send an extra message to the argument. And we'll use late binding so that the correct method is executed. So this is, at the end, this is super simple. Now what you should pay attention is that if you use double dispatch, you can make the program execution a bit difficult to follow for people when they are debugging or things like that, because suddenly another object can receive a message that and you were not expecting it or things like that, because at runtime it happened. But when you read the code, especially typically when you have a dynamically typed languages, this may not be obvious. You should pay attention that this is potentially a drawback of the solution.